But yours came off, so you had a little fire into it.
Damn, those are the days.
Maybe tomorrow, right?
You know how one of those phones,
We actually
you have
got
to
the
go
room
like,
we start running the pasta.
you have to wait like an hour for the
Right.
to
Yeah, exactly that here. Yeah, we have you two guest speakers for that.
I'm waiting for technology to catch up.
Oh.
Somewhere, you okay?
Isn't everybody? Hi, Dr. Ing.
Hey, there you are. Hey, that's powerful.
Yeah, me and Barack run in the same circles.
Somebody had their coffee this morning.
So Dr. Ian, what are we doing last today? Cancel.
Oh, you're so anxious.
Just wake up in
Are
the
we
morning,
starting the next
run,
experiment?
work out,
Are we starting the next experiment? Okay.
Have a
Yeah,
cup of tea,
starting
home,
a new
go to sleep.
experiment.
Coffee's the devil's
So we're
food.
just drawing stuff
I
today.
know.
No, I just.
I know.
Just preparation.
I did Hail Mary.
I finished it.
Oh man, let me get some.
You weren't wrong.
No, oh, y'all think that you got milk?
I finished because I ran out of apples. I finished because I ran out of apples.
Oh, you ran.
I got my sandwich. My bag.
Yes.
I got a 5-cup sandwich.
Is it technology you want or
Huh?
How's that working out for you?
It's working out okay. Okay, there you go.
Okay, that's where we stopped last time. I highlighted the magic number here. So remember that in order to have two endpoints, you need this ratio, 10 to the 4th. Change your lucky seat, huh?
Nah, I just changed my seat.
Oh. Okay, here is an example. Phosphoric acid is a polyprotic acid. So there will be 3 protons be able to come out of H3PO4. So if you titrate H3PO4 against a base, how many endpoints you're going to get? Okay, then look at the Ka value, because we need to calculate the Ka ratio in order to determine how many breaks. So these values are available in the table. Okay, then notice the magnitude getting smaller and smaller. It makes sense because this is, you can see a charge number minus, so the H plus will be more reluctant to come out. Okay, so it still comes out, but with a small value, 10 to the minus 8. Then notice this has a proton to come out, yet its charge is 2 minus, so it will be even more reluctant, right? So indeed, the number reflects that. So they come out as protons. So if you titrate these protons against sodium hydroxide, how many breaks should you get? You might think that, okay, what's the problem? I will have 3 breaks. Not so soon. Let's see what happens. Well, between Ka1 and Ka2, the ratio, okay, the magic number 10 to the 4th, okay, this is larger. So you will get an endpoint right there, a break in a titration curve. Okay, you're going to get one. Then what about between A2 and A3, the magnitude comparison? You still get one. So far you get 2 endpoints. Now what about the last one? The last proton, be careful. The last proton is going to be compared with Kw. Highlights this. Well, this titration is performed in water. Water, Kw 10 to minus 14. You're not going to get an endpoint. Okay, very important understanding. Then if you say, okay, knowing this knowledge, if I use a solvent, the K of solvent is 10 to the, let's say, minus 19, right? Then your ratio will be larger. Then 10 to the 4th, you will get an endpoint. So here explains one reason for you to use non-aqueous solvent for titration, for the reason of getting an endpoint here, okay? So make that to be a note. Okay, then what about the endpoints pH? One can approximate the endpoints pH for the first break. Will be pKa1 plus pKa2 divided by 2. Then you get the endpoints pH right there, etc. Second endpoint, then you use the next 2 Ka values divided by 2. So we had derived the expressions before, so now you can use them for the estimate. Any question with that?
So, so if anything is larger than 10 to, if you get a power 10 to the 4th, then
You get a break in your titration curve.
okay.
Yeah.
But anything under that, it's,
No, then it will be just fused with the previous endpoint.
oh, okay.
Yeah. So the important point here, I might ask you, then in order to see this endpoint, what should you do? Then you would say that, okay, instead of using water, I will use ethyl alcohol, which is K value is 10 to the minus 19. Then you can see the break. Okay? Okay, so there we are talking about endpoints detection based on human eyes, color change. So the indicator itself is a weak acid, okay? Because it's an acid and base indicator, so itself is a base or an acid. So here represents the indicator, the formula, before the endpoints, that the proton is intact to the formula, so you have the color of the formula, the HIN. Now at the endpoint, once that concentration is reached at equilibrium, so this is your endpoints proton concentration, that your indicator will be at equilibrium with that, and ionize to give the anion indicator, then this color will be different, okay? And this is the color you try to catch for, because this is your endpoints pH, okay? Okay, so the point number 1 is the endpoints pH at the endpoint, then this guy, just like the equation, will ionize into this guy. So you will catch this color. So what it amounts to, the first appearance of this color is what you're trying to catch. So you try to catch the transition color at equilibrium, right? So the smallest concentration of that. Human eyes, by human eyes. It turns out that by human eyes, if the ratio of the two concentration at equilibrium being 10 to 1, then you will see the color before the endpoint. So the transition concentration ratio is 10 to 1, then you see this color. On the other hand, 10 to 1, opposite 10 to 1, then would be certainly of this color. But then you are trying to catch somewhat in between, right? So the earliest possible from this ratio, okay? So, and therefore, there's a limitation. We call that your detection limit based on human eyes. So unless you are instrument, you can see better. So that would be your detection limit requiring your indicator allow to have the 10 to 1, 1 to 10 ratio. So we can mathematically derive for the detection limit. So let's look at that. So that becomes a requirement for a successful indicator.